Hello, students. Welcome to today's session. Sorry for the glitch. I hope now I am audible for you. Please respond in the chat box. And my name is Ranjit. You are here for exclusive, comprehensive recruitment training hosted by Seven Sense. I'll be handling cubes and keyboards today. Uh, Please let me know that I'm not talking to ghosts. You there? I'm the only person. Hello. Good afternoon, Vidya. Nice to know that you are here. Good afternoon, Rakshika, Tejashri. Yep, I'm audible. Thank you. I'm audible. You are visible. There are three people in my class today. Yay. Only three people? Oh, so we are talking personal stuff today. Okay, Sandip, good afternoon, Sandip. Swapna, good afternoon. Good afternoon, Parvati. Hi, I'm very nice. How are you, by the way? Hi, Chetana. Good afternoon. Madam, my voice sounds like Madam Chetana. So sad. If you guys have Chetana right next to you, I'll give you the permission to kill her. Attack. Good afternoon, Rashmi. Good afternoon, Samya. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's low. 10 people have responded so far. That's a miracle. Oh God. Well, let me just start the PPT so that we can get on to the topics. So, how are you guys doing? So, how's the weather? Random talks, random chit chat till we start the class. Deepa. Good afternoon, Deepa. Good afternoon, Tejaswini. I hope now the screen is visible. Good afternoon, Vikram. Sir, had your lunch? I had a huge breakfast that is making me not to eat lunch. So this is the cubes and cuboids we have. See, such a wonderful shape the cubes are. Huh. Human beings, we are capable of analyzing. Good afternoon, Sachin. Huh. So we are capable of only looking at 3D objects. We can't. Our eyes can't perceive any other dimensions. But three dimensions The three dimensions, right? I hope before coming to cubes and cuboids. So today we have internals at 3 p.m. What a pleasant news, Chandramali. Good luck. Bunk my class after 3 p.m. That's what you're going to do anyways, whether I say it or not. Hmm. Okay. I don't want this. I'll keep this. Chalo, let's start the session. So I hope you understand the basics of geometry before coming here, because cubes, it is a geometrical element, right? You should know the attributes of what a cube is. Can anybody define? How do you define a cube? Can anybody try to define a cube? Look, rule number one in my session. I don't know how many of you already have met me before, had class with me. There might be some people here, there might not be anybody. But rule number one in my class: when I talk to you, you talk to me. I know online classes restricts us not to talk like words to words, but chat to chat. No matter how small chat you make, you put y n 10, true false, I don't care, but keep using the chat box exclusively so that I will not sleep, or else I'll sleep and you can write your internals. Simple as that. Huh. Okay. Cubes. I have this wire. I had to cut this wire. This. Then connect it here. Symmetrically three-dimensional shape and solid or hollow, 6 equal squares. Wow, Shubham, exclusively great. We are now doing exclusive comprehensive recruitment training. Yes, this is really an exclusive answer. Symmetrically three-dimensional shape. Yes, it is symmetrical in all the dimensions actually. In all the planes, if you can consider planes, x plane, y plane, z plane, it is symmetrical. It has it can be solid or hollow. It has 6 equal squares. Of course, it has 6 equal squares as faces. Um, so this will be our whiteboard, and this will be our mhm, hmm. Now if you look at this, if you look at this, um, okay, before going there, can anybody tell me what are the zero dimension entities that you know? Can you guys tell me what are the zero dimension entities that you know? What are the one dimension, zero dimension, and two dimension and three dimension entities? Basic entities, any element. Wow, that's a great answer, Sandeep. So zero dimension entity, Sandeep says it's a point. Full stop. Yeah, nice. Nicely done. So we have zero dimension, we have one dimension, two dimension, three dimension. What are these dimensions? Uh, if you want me to explain, ask me what are the dimensions, I would say the number of axes or number of directions required to describe a shape is called as a dimension. Minimum number of axes or directions required. Let's say I have a square. I have a square. Square. Let's draw a square. If I had to describe the square, uh, I can say it is 2 centimeter in x direction or axis, whatever you call it. I know you guys are engineers and there's a lot of confusion between directions and axis and all those things. Please bear with me. I'll try to use layman words. So I'm using direction rather than axis. So I can say it is 2 meter in y direction. So to define this square, I need two directions. So that two directions represents the square as a two-dimension entity. Now, if I want to define a point, how many directions are required? Can I call it? It is x meter in. Let's say it is 3 meter in x direction or 2 meter in y direction. There is no requirement of any directions or there is no requirement of any dimensions to uh, define this. The point is an hypothetical element which is considered zero in all the directions possible. You go anyways in all the directions, it is considered as zero. That's why it is a zero dimension entity, the point. And and you guys know that one dimension entity is a line. One dimension entity is a line. Can anybody define a line for me? Can anybody define a line for me? Somebody, anybody, whoever concerned, define a line. Points of set. Good afternoon. Good afternoon, Mohammed. Points of set. You mean set of points? That would make more grammatical sense. Yeah, Mohammed. Thank you. Nice answer. Anybody else? Why is that only one person or two-person had to give me an answer? Nisha, Sandeep, Shubham, कहाँ गए आप लोग? Where are you guys? Set of points. Set of points and straight lines. Typing mistake. Okay, Mohammed, not a problem. As long as you give me an answer, no matter what answer you give, it does not matter. And set of points and straight line. Yes, everyone get back to the same answer. Can copy paste that. Collection of points. Yes. Okay, what's the length of a point? What's the length of a point? I will show you a mathematical paradox or a mathematical discrepancy or whatever you know about counting numbers. I'll prove it wrong for you today. Length of a point is infinity. It has infinite length, Kismet. Or should I call you Nisha? Or what should I call you? Kismet. Kismet sounds nice. Slide is very small. Okay, slide become bigger. Now, what's the length of a point? Ankit, yes, Ankit, I'm so sorry. Huh. Now I think it should be better. Is it better now? And just tell me what's the length of a point. Come on, guys. Come on. Quick, quick, quick. Exactly, Sandeep. So what's the length of the point? You're right. But tell me what's the length of a point? Quickly. You guys know the answer. It's waiting. It is up to us to define the length of the point, Umar. Really. I just spoke about a point a moment ago. It's a zero dimension. No matter which dimension you go, there is absolutely no length to it. It is absolutely zero. It's not zero to infinity. It can't be infinity. If it is infinite length, it has a dimension to it. It is absolutely zero. Point has no length, correct? The length is zero. No length means zero, right? Right, Sandeep? I want you to put it in numbers rather than words. Both of it makes sense, right? Same sense. Shubham, right? All Vidya, Ankit, Kaveri, Rakshita. Great. Length of a point is zero. Now the magic happens. Now, what's the line? What's the line? Collection of points. I should have taken other color. Collection of infinite points. To be more accurate, collection of always infinite point. Always it is infinite points. Earlier people told me it is collection of points. Please make sure you understand this word. This is more important. It's not just collection of points. Collection of points, when you're saying it is finite, no, it is collection of infinite points. Whether the length of the line, whether the length of the line is equal to 1 meter, still it has infinite points. If it's equal to 100 meter, it is still infinite points. If it's equal to 1,000 meter, 10,000 meter, 10 lakh meter, or even the length is equal to infinity, even then it has infinite number of points. Even then it has infinite number of points. This is the proper definition of a line, collection of infinite points in any one particular direction. In any one particular uh, direction. That makes it a straight line. If it is multiple directions are involved, it can be still a line, but it can be curved line or an arc or whatever you guys know about other things. Now, now the food for your thought, yeah, whatever that nonsense is. This is collection of points, right? Um, can anybody tell me what is 0 plus 0 plus 0 plus 0 plus 0? X is equal to how much? If it is 0 plus 0 plus 0 plus 0 plus 0, how much it is? I have a variable x and I say x is equal to 0 plus 0 plus 0 plus 0. Yeah. Very easy answer, right? Bilal gives 0 0 0 0 0 0. Sana gives 0. Rakshita says 0. Sorry. Sorry to disappoint you. 0 plus 0 plus 0 plus 0 0 plus 0 0 up to infinite zeros can be 100. Can be 1,000 also. Can be infinity also. Proof is here. This is the proof. This is the proof. And hence proved. And hence proved. Look, please don't tell me just because line is made up of collection of infinite points. Does every line, it can be 100 madam, it can be 1,000 madam, Sana madam, it can be even infinity madam. That's why 0 to the power of infinity even today is even today defined as indeterminate. This is the best. Look, mathematics. If you want to understand mathematics, the mother of mathematics is geometry. Mother of mathematics is geometry. If you understand geometry properly, you understand mathematics properly. Look, what's the length of this point? Zero. Length of this point? Zero. Length of this point? Zero. Zero plus zero plus zero plus zero plus zero. Are you telling length of this line is also zero? Length of this line is zero. How many of you say length of this line is zero? Say yes if you consider the length of this line as zero. Say no if length of the line can be any finite number, any finite, or even it can be infinite number. Say no. Bilal says no. Good, Bilal. Only one. Others are confused. Sir, I'm not able to follow you, sir. What are you showing? Something magical is happening here. No, yes. No, no. Chandramouli, Daniel, Rakshita, Vidya, all says no. Look, length of the line will be definitely a concrete, a finite number. But you already know that line itself is formed by collecting points, and the weight of each point is zero. By collecting zeros, we made number out of it. How is that possible? That goes beyond our common sense, and that's why it is called as an indeterminate. That's why it is called as indeterminate. I'm sure you have read 7 or 8 standard indeterminate for forms in your 12th grade. But understanding that is very very tough. And this is one of the example where you will definitely try to relate it. Length of the line can be any number. It can be 1 meter in length, or 1,000 meter in length, 1 lakh meter in length. But number of points it is made up of is infinite. Look, between 0 to 1, how many numbers are there? Decimal numbers. How many numbers are there between 0 to 1? As many as there are between 0 to 100. Confusing, right? Please do not try to talk about these three numbers in front of me: 1, 0, and infinity. You and me will never understand this. I won't say I will not understand that. As of today, you won't understand that. Now, one dimension entity is done. Two dimension. Let's move on to the two dimension. Two dimension is made. Let's say I want to make a square. So just like one dimension, if it is collection of points, this is collection of infinite finite lines. Collection of infinite lines. If I keep collecting lines like this, look, I'm definitely writing something to make you visibly understand. I'm writing finite number of points and lines, but that does not mean it is finite. It is, I'm trying to make you visualize something infinite. If you truly had to imagine something infinite, go and watch uh, uh, pre-climax scene, pre-climax scene in. I hope you guys have watched this movie. If you haven't watched this movie, big ass, go and watch it now. Okay. The collection of infinite lines, if you pile line over line over line over line, you will get uh, an area. And 3D, if you pile infinite areas, or in other words called as planes, if you pile them up, if you pile them up, you'll get volume. This is how the logic of geometry works. If you keep piling them, Watched. Ankit, good. Ankit. I'm very bad at drawing as of now. No, I'm actually very good at drawing, but right now I don't know how you are feeling about that. Sandeep, good. Others, they don't understand half of my jokes. They don't want to respond to me. One word also is very hard for them to type. Use laptop, guys. You are engineering students, fifth semester probably. Use laptop to come to online classes. Don't use mobiles. I know mobiles are comfortable, but not for typing and chatting and all those stuff. Yeah, come back. So we are going to use this concept to understand how the cubes work. How cubes work. I'll start up with this. Now, if you problems in cubes and cuboids will be like this Rubik cube. It is not actually a Rubik cube. It's an higher version or an extended version of a Rubik cube. You know how many small boxes will be there in a Rubik cube? It is mostly it is 3 cross 3 cross 3. That's what we call as Rubik cube. Here it is something cross something cross something. So don't worry, this is not a Rubik cube. Something looks like a Rubik cube. What we do in cubes problem is, oh, you are in seventh sem, huh? And you don't have a laptop, or you don't prefer to use laptop for online classes. So sad, so sad. Huh. Chalo. So what do we do in cubes problem is we take a huge cube and paint it with the different colors on different faces. Like this cube here, it is painted red on top, blue on one side, and white on the front. It might be painted with different colors on the other faces. So now let's understand the geometrical perspective of this cube. If you can uh, if you can see this, there are all these are called as corners of a cube. All these are called as corners of a cube, and corners are basically geometrically represents points. You need to understand they represent points, and they have the characteristics of a point. And then we have lines. Those represent the edges of the cube. All these marked are the lines, the 12 edges. How many edges are there? How many corners are there? Please count it right away. There are 8 corners and there are 12 edges. And if you can look at this, they have 6 faces. They have 6 faces. Okay, Kamala, that's nice. That's okay. I accept your problems. They have always have. Then use a sandbox, guys. Use a sandbox. Um, put a simulator of a mobile inside your laptop. Come on, you guys are 21st century kids. I should come up with ideas for you. I'm 20th century old guy. I'm not old, but I'm telling I'm 20th century guys. Do not question. Come on, come back and concentrate here. So um, hmm, 8 vertices, 8 corners. The corners means they represent points. Points definitely means zero dimension entity. Lines are one dimensional entities. See, Sandeep has a better idea. Buy Kurkure and Lays, they'll give you 2 GB data free, and you still complain. Good, Sandeep. Have snacks while listening to the class. Yeah. At least there is one happy kid in my class. Thanks you so much, Sandeep. You made my day. Others, Sadu guys. How old are you guys? Huh. Yes, so this is giving me a trouble. Ashwini Bhatt. Yes, Ashwini. Okay. I can't play this. How come I change this position? Yeah, this works fine for me. See, now we'll talk about if you take up a big if you take up a big cube and try to color like this red, blue, and white, and cut it into smaller cubes. Now, my next question is, how many three-side painted cubes are there? How many three-side painted cubes are there? Uh, can anybody tell me where do you find this three-side painted cubes? Where do you find this three-side painted cubes? Yeah, everything is revealed. Vertices. Very good, Sandeep. It is found in vertices. It is found in the corners or it is found in the vertices. I, I'm I'm not able to control the PPT properly because of the two screens, multiple screens. Yeah, so it is definitely found. If you can observe this point, uh, in this corner, this particular cube is painted three sides. There's no other cube in this entire set. There's no other cube in this entire set which has more than two side painted. Only in the corners there are three side painted. Because why in the corners it is three side painted? Because three faces are coming come and meet at that particular place. Blue face, white face, and the red face. All of these faces meet only in the corners. Meet only in the corners. So and hence there are. If you take any cube and in this particular manner, how many cubes will be three side painted? How many cubes will be three side painted? Ding ding. How many cubes will be three side painted? Count and let me know. I've tried to make it as pictorial as possible so that you can understand it. Oh, you guys are sleeping? Yes, three side. I'm talking about three side painted. In this particular cube, how many are three side painted? Right, Ashwini? I will come to that. Vidya says there are eight cubes. Sandeep says eight cubes. Only two or three people are responding really good. What happened to the rest of you guys? Come on, don't make me sad. I'm already sad. Sanjana says eight cubes. Three people has answered an easy question. Four. Tejaswini, congratulations. Bye, Shoaib. Yes. So, no matter which cube you take, and how many cuts you make, no matter which cube you take and how many cuts you make, this particular quantity is always fixed. Whatever cube you take, and cube or cuboid or whatever you take, and no matter how many cuts you make three cuts or like this seven cuts n number of cuts you try to make, number of three side painted will always be fixed as 8. Why it will always be fixed? Why it is a constant? Because the equation goes like this. The equation goes like this. See, 8 into x power of 0. Why power of 0? Because points are zero dimension. Points are zero dimension, and zero dimension represents, look, you know the equations of a line or an area or whatever you guys know. Equation of a line is y is equal to mx plus c. What's the order of the equation? Order of the equation. What's the order of the equation? Line as what's the order of the equation of line? What is the order of equation of a line? You know y is equal to mx plus c. Ding dong. Hello, knock knock. Anybody home? Hello. Yes, Sandeep, Vidya, and Ashwini. Thank you, guys. At least some people saved. The order of the equation is the first order, or you can just plainly say one. Do you know why it is one? Because a line is one dimension. Line is one dimension. Now, if you want to express a square is defined as equal y is equal to x square. The order of the equation in this case, second order. Why it is second order? Because it's a two dimension. And if you want to define a cube, every cubic equation will define a cube. You need to understand moment. Wherever you see x square plus y plus z, whatever you see, it means this is a equation which defines a diagram which is two dimension, that's what you should understand. Whether I think you have learned through a lot of curves or diagrams in M1, M2, M3, M4, whatever you have read. Probably you have went through cardioid, we have went through a hyperbola, you went through parabola. Moment if there the power is two, you should think it is a two dimension, and moment if there is three, you should think it is a cubic or three dimension entity. Moment if it is four, you should think of leaving it. You should never try to imagine how a four dimension looks. It's not capable for our primitive minds. We are not capable of doing that. So just skip. Probably one day, if you become as good as Srinivasan Ramanujam or Euclid or Aryabhata, no, not Aryabhata was much more primitive. Ape people. Ha. You guys are big ape people. 21st century ape. Yeah. Yeah, I'm much more primitive. I'm 20th century ape. Don't worry. Uh, so we'll continue. Please keep this in mind. And one more thing I wanted to talk about before heading on to like higher order equations here. The last thing here, if you see this big cube is sliced. How many slices are there? How many black lines are there in? Let's call this as an x direction. Uh, let's call this blue line as x direction. How many slices are there in x direction? Can anybody tell me? One, two, three, four, five, six slices. How many cubes are there here? Guys, you guys become very slow, or am I? Is there a huge lag? How many slices are there in the x direction? X direction. How many slices are there, and how many cubes are there in x direction? Cube is third order. Yes. Yeah, that's right. Now nobody answering. Everybody left. I will also sleep. Yes, Sandeep. There are six slices and there are seven cubes. Okay. Even if you that's in the x direction. Now let's take. We had to go to y direction. Let's say we go in this direction, y direction. Even in this direction, if you observe, there are six slices and seven cube. And even this is x, this is y, and there's one more direction called as z direction. Even if you take up a z direction, that is top to bottom, top to bottom, one, two, three. There are six slices and seven cubes. Can anybody tell me? Can anybody tell me how many totally how many small cubes are there? Totally how many small cubes are there? Totally how many small cubes are there in this entire set of small cubes? Totally how many small cubes are there? Uh, Mohammed Ferris says 294. And now, understanding this set of small cubes is as good as understanding matrix. You guys know matrix, right? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the dimension of this matrix? What's the dimension of this matrix? It's a 3 cross 3 matrix. If it's a 3 cross 3 matrix, can anybody tell me total how many numbers are there? Total how many numbers are there? You know what do you mean by this 3 cross 3? There are three elements in x direction, and there are three elements in y direction. Madhavi, 1 second. I'll explain that part. How there are seven cubes. I'll show you count and I'll show you. There are three elements in x direction and there are three elements in y direction. Totally, how many numbers are there? Oh God, this is such a boring class. Why can't you guys reply? How many elements are there? Count and tell me. I gave you a simple example so that you can count. ಒಂದು ಎರಡು ಮೂರು ನಾಲ್ಕು ಐದು ಆರು ಏಳು ಎಂಟು ಒಂಬತ್ತು. Yeah. Why is that only one person had to reply or two people had to reply? Yeah, thank you guys. Nine. So how did we get that? It is 3 cross 3 is equal to 9. Now let's say I write a three-dimension matrix. You know what is three-dimension matrix? Let's say I write 4, 5, 6, 7, 8, 9. This is so this is I know I'm making the diagram look very weird and complicated, but this is how you are supposed to imagine this. Okay. Um, this is a three-dimension matrix. If you guys are computer science engineers, I'm very sure you guys have dealt with many arrays like this. Many arrays like this. Can you tell me what is in this case? It is not just m into n. It is m into n into o, m into n into o. Can you tell me what's the dimension of this three-dimension matrix? It would be 3 cross 3 cross 3. It would be 3 cross 3 cross 3. If it is 3 cross 3 cross 3, can you tell me totally how many numbers are there in this three-dimension array or three-dimension matrix? Totally how many numbers are there? Yes, Sandeep. You guys are not, you don't understand my tongue. I understand any tongue that you say. Very good, sure. Others, 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 others. Yaradru, there are others. Yes, Rutuda. Yes, Rashmi. So totally, the total number of elements in this three-dimension matrix or three-dimension array is 27 because it has the dimension of 3 into 3 into 3. 3 cross 3 cross 3 would give you 27. Now, yeah, somebody asked me why there are seven cubes. Now let me count. Can't it be ungrouped? So now let me count. Look, this is the first cube. This is the second cube. This is the third cube. This is the fourth cube, fifth, sixth, seventh cube. So you can say there are seven cubes in x direction. Similarly, if you consider the y direction, first cube in the y direction, let's say I'll take this. First cube in the y direction, second cube in the y direction, third cube in the y direction, fourth, fifth, sixth, and seventh. So there are seven cubes in x direction, seven cubes in y direction, and z, the vertical one. One, two, three, four, five, six, seven. Five, six, seven. So there are seven cubes in z direction. This is also exactly like your three-dimensional array or three-dimensional matrix. Can anybody tell me what is m, n, and o of this? M, n, and o of this? And totally how many cubes are there? What is m, n, and o of this? And totally how many cubes are there? Whoever asked why it is seven cubes earlier, did you understand now? Do I need to, Madhavi? Yeah, Madhavi, did you understand it? Do I need to repeat the explanation here? Yeah, can you tell me the dimensions show up m, n, and o? What are the dimensions? What are the m cross n cross o? Actually, in this case, I would rather define it as x cross y cross z, x cross y cross z. So it is 7 cross 7 cross 7. So totally number of cubes would be 343. 7 into 7 into 7 is 343. What is this, Chandan? You multiply 343 by 7, is it? This is not a four-dimension entity. This is three-dimension. Highest possible is x cube. I told you if it's fourth dimension, forget it. Forget it. You can't imagine fourth dimension. Can anybody tell me what is fourth dimension cube is called as? Any Avengers fan here? Any Avengers fan? Does anybody knows what the fourth dimension cube is called? Please do not Google. If you know, please tell me. If you don't know, just say IDK. People who say IDK are much more prettier than people who think they know everything. Do you know what fourth dimension cube is called as? Okay, so please keep this in mind. Please keep this in mind. It is x, x, and x. Now, in considering the same logic, can anybody tell me in this front face, totally how many small cubes are there? Only on this face, only on this face. And what is the dimension of it? You need to give me dimension rather than the final number. I know you can multiply and give me the final answer anyways. Just give me the dimension of this front face. How do you define this front face? How do you define this as front face? Very good, Sandip. The front face will be defined as others, others. Correct, Madhavi. Two dimensional, of course, it is 49. Yes, right. I know 49. You can 7 cross 7. Now, my next question is, now let's take an hypothetical cube. Let's take an hypothetical cube. Uh, let's take an hypothetical cube. Let's take an hypothetical cube. Correct, Sandeep. So this will be, if you understood so far whatever I've told you, if you understand so far whatever I've told you, you will derive the formulas. You will derive the formulas for all the situation. The first question that comes under cubes is, let's say in this direction, in x direction, there are x number of cubes, and in y direction there are x number of cubes, and in z direction there are x number of cubes. Can anybody tell me totally how many small cubes are there? Totally how many small cubes? Please, your answer. There are x number of cubes in x direction, x number of cubes in y direction, x number of cubes in z direction. Very good, sir. You need to understand it is x cross x, that will be equal to x cube. That will be equal to x cube. Now the second question. How many small cubes? How many small cubes are three side painted? This also we have already dealt. How many small cubes are three side painted? Very good. It's x cube. Chandan, Vidya, Madhavi, Sandeep, sir. Great. So how many small cubes are three side painted? The second question is, how many small cubes are three side painted? Very good, sure. Very good, Sandeep. We have already dealt. The three side painted will be only there in the corners. And so this corners represents a point. So this will be 8 into x power of 0. That means it's a constant. That literally means This is a constant. It's not an equation. It's a constant. X power of 0. You guys have done differentiation and integration a lot of times. So the next question is, I hope by now you have understood uh, the concept that I'm trying to explain. The next question is interesting. Think, think, uh, think, and let me know how do you answer this. How many, how many small cubes, how many small cubes are two-side painted? Look, I'm creating a mindset that uh, you can imagine and derive a generalized equation for all the situation. You can derive a generalized equation. Look, consider x only. Consider x only. I'll shift back to the old slide. I know in the old slide there are 7 cubes and 7 cubes and 7 cubes. Don't consider 7. Please consider x cubes in x direction, x cubes in y direction, and x cubes in z direction. And please answer this: how many small cubes are two-side painted? But before answering that, before answering that, can anybody tell me? Can anybody tell me where do you find two-side painted cubes? Look at this diagram. I've put this diagram so that you can tell me, uh, you can understand and let me know where do you find two-side painted cubes? Where do you find two-side painted cubes? Ashwini, come on, don't consider 7. Please don't consider 7. Please consider it as x. I want a generalized equation, not answer for this particular question. Where do you? I know this diagram looks 7, 7, 7, but imagine it as x. So your answer should be also in terms of x only. Your answer should be also in terms of. Very good, Sandeep. Where do you find two-dimension or two-side painted cubes? On every edge. On every edge. On every edge, there are two-side painted cubes. On every edge, there are two-side painted cubes. Abhishek, this is the first answer you have given so far. A wonderful try. A wonderful try. Nice answer. Love you. Okay, now please, others who are just listening and not trying to participate, please participate. You will understand much better, and I'll also have more energy. Right now I'm feeling bored. So if you observe any edge, if you observe any edge, all the cubes in these edges are minimum two-side painted. Minimum two-side painted. Why I say minimum painted? Because uh, this cube is two-side painted. Agreed. This is two-side painted. All of these are two-side painted. But this corner one is three-side painted. This corner one is, that's also three-side painted. I don't need three-side painted. I only need two-side painted. Can you tell me in this edge, let's say we have already considered, again Suresh, please don't consider 7. In this edge, totally there are x number of cubes. In this edge, totally there are x number of cubes. Can anybody tell me out of this x number of cubes, how many are only two-side painted? How many are only two-side painted? This edge, there are x number of cubes. How many are only two-side painted? On that particular edge only. Sandeep says x minus 2. Anybody else? Oh God, Shoaib, why Shoaib? Only on this edge, only on this edge. I'm talking about only on this edge. Look, when I ask you a question, think of only that question. Don't think of something I asked 10 minutes ago. You will get confused and you will not understand. I go step by step for a reason. If you look at this edge, and if there are x cubes in this edge, how many of them are only two-side painted? So x minus 2. That's a great answer. X minus 2 is a great answer. Now the question is we have already previously established how many edges are there in a cube. How many edges are there in a cube? If you look at this diagram, you will get to know how many edges are there in a cube. Why I'm coming back to this diagram? Because it's already marked, well marked. There are totally 12 edges. There are totally 12 edges. I think there's a lag between the screen and the voice. Am I right? There's a huge lag between screen and the voice. So can you guess totally in this entire set of cubes, totally in this entire set of cubes, how many cubes are only two side painted? In this entire set of cubes, how many cubes are only two side painted? Good, Sandeep. Good, good. We are creating. Please understand, we are deriving a generalized equation. We are not giving answer for a one particular scenario. We are giving answer for every scenario. And why it is 12 and why it is x minus 2. I hope everyone understood why it is 12 and why it is x minus 2. Yes, very good. It is 12 into x minus 2. It is 12 into x minus 2. See, since three side painted are always defined by points or vertices, it is zero dimension equation or zeroth order equation. Here it is defined by edges. Edges means lines. That's why the order of the equation is 1. The order of the equation is 1. Now let's move on. Let's move on and ask one more difficult question. If you really understand this, you did magics. How many small cubes? How many small cubes are only one side painted? I should have given only everywhere, only one side painted. How many small cubes are only one side painted? I'll go back to the previous diagram. I'll go back to the previous diagram so that you can imagine the things. Where do you first think of, where do you find one side painted cubes? Only one side painted cubes. It should not be a two side painted. It should be only one side painted. Sandeep, please answer my question, Sandeep. Where do you find one side painted cubes? Come on, come on. I've already given you relationship between order of the equation and what does that order of the equation represents. You're talking about a cubic equation. And then directly went into the answer. He went to n minus 2. Chandan, I hope you are not checking out Google right now. I hope you are not checking out Google. Yes, the answer, you guys are exactly right. It will be on the faces. If you look at this entire face, if you look at this entire face, you will find all these, the center, all the center wale, at least they are only one side painted. Look, the edges wale, they are either two side painted or three side painted. I don't need this edges. I don't need this edges. I need only center things. So on this face, now let's count how many faces are one side painted. Now let's say in if I go in x direction, if I go in x direction, can I consider all the columns? Can I consider this column, this column, this column? How many columns can I consider? Let's say if there are x columns, if there are x columns here, how many columns can I consider in x direction? How many columns can I consider? Quick, guys, time is running out. Okay, Chandan, let's not consider 7. Let's consider X. X, generalized. Generalized. Yeah, Vidya, great. You gave me the final answer. Come back to yes. X minus 2. Oh, Bhumika, a new person added into the group. Yes, Bhumika. Yeah. Great. So X minus 2. In X direction, I can consider only X minus 2 columns. Now let's do Y direction. Can I consider all the rows? Can I consider all the rows? If there are X rows, how many rows can I consider? How many rows I can consider? I'm talking in terms of matrix, rows and columns, so that you can relate it easily. So now tell me on this phase. Now tell me on this phase. Totally, how many cubes are only one side painted? Totally, how many cubes are only one side painted? On this phase, you can consider x minus 2 columns and you can consider x minus 2 rows. Totally, how many of them are only like this 1, 2, 3, 4, 5, 6, 7, 8? This is also a matrix. Okay, this is a okay. Vidya, again you're going considering 7. Please consider x. Very good, Sandeep. Why I know the diagram is of 7. Look, I cannot create a diagram which has x number of cubes. Is it possible? Variable. Umar, come on, Umar. Very good, Chandan. It is x minus 2 into x minus 2. That's the best answer. It is x minus 2 into x minus 2. I can consider x minus 2 rows and x minus 2 columns. So it is x minus 2 into x minus 2. How did you come up with 36? X minus 2 whole square. So on this space alone, there are x minus 2 whole square number of uh, one side painted cubes, x minus 2 whole square. Like that face, how many faces are there? How many faces are there in the entire cube? How many faces are there? In one face, you can understand that there is x minus 2 whole square number. Yeah, Umar, if you consider it as 7, the answer is definitely 25. I would not say it is wrong. I'm just asking you, consider it as x. I want a generalized equation. There are 6 faces like this. So the final answer would be 6 into x minus 2 whole square. Simple as that. The final answer is 6 into x minus 2 whole square. 6 into x minus 2 whole square. I hope you are understanding the logic behind formula. I could have started the session by just writing down these formulas, like for any given particular condition. For one side painted 12 into x minus 2. For two side painted 6 into x minus 2 whole square. I could have given that and asked you to solve the problems. But there is no point if you don't understand the logic. If you understand the logic, no matter how twisted questions they ask you in quantitative aptitude, I hope you will be able to solve it. See, again, these are represented by faces. Faces are literally means areas. Areas means they are two-dimension entities. That's why the order of the equation is 2. That's why the order of the equation is 2. Which kind of method do you prefer? Sir, list out the formula and solve the problem, or give out the complete logic and make you create formulas? A or B? You can just say A or B. At least from today, I'll follow that at least. A is preferable, B is preferable. A means list the formula and solve the problems. B means explain the logic, understand the concept. Yeah, Sandeep, don't get confused. I've explained. Chandan says B. Vidya says B. Madhavi says B. Only three people say something. Haha. Come on. Now let's go to the last and final question. How many? Look, I am teaching you. I'm teaching you easy question. Okay. I'll let you do the complicated question on your own. Sandeep is still thinking. Only three people answered. Rest of them are sleeping. Wake up, or I'll shout in your ears. I know most of you are wearing a earphone. Should I shout? Should I shout loud? You'll wake up. Sandeep is B. Others, they don't care at all. Are no side painted. How many small cubes are no side painted? Where do you find this no side painted cubes? If you look at all of these, all the surfaces are painted. All the surfaces are painted. Where do you find the no side painted cubes? Where do you find no side painted cubes? Finally, the answer is correct, Sandeep. I hope now you have understood the concept. The no side painted will be inside. These are the layers of cubes stacked upon one over the one. In the middle, there will be one small cube. On top of that, one more layer, one more layer, one more layer, one more layer, one more layer to make big cube, right? So you need to like slice out this top layer. You need to remove top layer. You need to remove bottom layer completely. The complete layer, complete face you need to remove. If you remove top layer and bottom layer, the unpainted surface will be visible. And you need to remove the front layer and the back layer. In every dimension you need to. Dimension mean the direction, x direction, y direction, and z direction. In every direction, you need to remove two layers. And finally, you will end up with the core. Core, again, it will be represented by as volume. Core will be represented as volume. And in that volume, you'll find the three side, no side painted cube. And how many of them will be there? X minus 2 whole cube. 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 I hope everyone understood whatever I have done so far. Now, can you, if you let me to continue with the difficult one, now I'll not explain anything for you. Now I'll not explain anything for you, but I will demand an answer. I'll demand answers from you. So please, so far we dealt with cubes. So far we dealt with cubes. Now we will be dealing with something called as uh, cuboid. I'll try to make the diagram itself as self-explanatory as possible. But if you still don't have a good imagination power, um, sorry, I'll not be able to help you much. You need to have a good imaginative power and very good understanding of whatever I've done so far to be able to answer these questions. No big difference. These are the same questions as previously we have discussed, but it's a different scenario though. Please don't call it as cube. This is not a cube. This is a rectangular cube. Yeah, you can call it as a rectangular cube, but a rectangular cube is called generally called as a cuboid. Let's consider um, uh, green as x direction. X direction. In x direction, in x direction there are x cubes. In x direction there are x cubes. Let's consider blue as y direction, and in y direction there are y cubes. Number of cubes. A generalized equation we want to solve, right? So that's why I'm making it generalized. Once you solve for generalized, no matter what question they give you, with whatever number they give you, it should not matter. And let's consider this red as z direction. In z direction, in z direction, there are z cubes. Question number one. Question one. Totally, how many cubes are there? Look, each direction, in each direction, there are slices like this. In each direction, there are slices like this. Don't, please, just because I'm writing the diagram, don't consider this is 3 slices, this is 4 slices, and all those things. Don't do that nonsense. Consider x, y, and z. Consider x, y, and z. Only that. Don't consider anything else. Oh, first question answer. Very good. Total number of small cubes are x into y into z. Great. Congratulations, people. X into y into z. I'm proud of you now. Now, the second question answer. Let's see the second question. Uh, only 3 side painted. Only 3 side painted. Very good. Now, look, this time if you are giving the answer, I'll not give any answer. I'll not give any explanation. You are going to give me answer. If you are listening properly, if you have understood, you'll be able to give me answer. If you have not understood, please ask me doubts. Until and unless you don't ask me doubts, I'll not be able to help you. And I intentionally not going to explain anything for you. So just I'll keep asking the question. Yes. Only 3 side painted cubes are 8. It's always fixed, no matter whether it's cube or cuboid or whatever it is. Look, earlier the diagram was so nice. Now I added this purple line. The diagram becomes so yuck. Oh god, disgusting. Okay, now moving on. Only 2 painted. Now this and the next question. This and the next question is the real test of your intelligence. Now let's see. Chandan, X Chandan. Huh? Are you telling all the edges are same, Chandan? Seriously, Chandan? Come on, Chandan. In all the edges there are x minus 2 cubes, Chandan. Is that the question, Chandan? Think, Chandan. Why am I saying only Chandan, Chandan, Chandan? I should say Sandeep, Chandan, Sandeep CM, Chandan DM. Wow, what a combination. Sure, Babu. Okay, two good answers. Two good answers. Congratulations, people. You have understood the cubes. Where is Abhishek? Where is Madhavi? Where is the others? Vidya. Mohammed Moin. Where are you guys? Did you understand? You're not understanding? Please let me know. How many green lines are there, guys? Check this out. Green lines means green lines. How many green lines are there? In each green line, how many cubes are there? In each green line, there are X number of cubes. Vidya got the answer. Very good, Vidya. And how many blue lines are there? So the answer would be x minus 2 into 4 plus, you can just write x minus 2 plus y minus 2 plus z minus 2, and each of these edges are 4. There are 4 edges of each of this: x minus 2, y minus 2, and z minus 2. So you can just write x minus 2 into 4 plus y minus 2 into 4 plus z minus 2 into 4. Now let's continue on and try to check if you got. Abdul Sattar has come up with 48. 48. 48. Chandan, where is addition symbol? Plus, we are multiplying all of it. It makes it a three-dimension equation. It should be single order equation. It should be single order equation. Yeah, Madhavi finally came back. Abdul, please do not consider the diagram that I have given. It is just to give you a basic understanding. Look, I can't write x number of lines in any direction, or y number of lines. I can only write some finite number of lines. That's why I've written like that. But don't consider that. Only one side painted. This is probably the most difficult question of all the questions. Only one side painted. Hmm? Shoaib, it is not into 12, dear. Totally, there are 12 edges, I accept. But there is 4 edges of x, there are 4 edges of y, and there are 4 edges of z. Totally, it is 12. 4 plus 4 plus 4 is 12. Please don't consider into 12. Please consider it as into 4, Shoaib. And please let me know if you still did not understand, I'll explain. I'll show you the diagram. You need the diagram. Yeah, yeah. Here. Madhavi, the cuboid is here. Yeah. You need. I know. For the first stage, for visualization purpose, you need this cuboid for understanding. I don't mind you use a cuboid, but logic is not that easy to understand. Okay, you are writing these equations very easily because you have already understood the logic of the cube. It is not that easy, and it's hard to even buy out these equations. You don't need to buy out these equations. Please understand the logic. If I take up geometry for you, I can teach you every formula that exists in geometry just like this. Forget geometry. You guys even don't know, perhaps even don't know what is a plus b whole square. A plus b whole cube is out of the picture. Well, now this time Chandan comes up with a clean shot, but not clean enough, Chandan. There are no squares, Chandan, in this cuboid. Sorry, Ankit. You are answering for the last question. Chandan, there is no square in any face. There are only rectangles, Chandan. Chandan hates me today. Shoaib, excellent work, Shoaib. Sandeep, excellent work. Chandan is getting confused. There are no squares, Chandan. That's all I want to tell you. I think you'll understand the moment I say there are no squares. There are only rectangles. Length is different, breadth is different. If both of them are same, yeah, there will be squares. Ankit, you are completely off of the target. You're out of the board. Oh, Nagra, Abhishek comes up with one complicated equation. Oh man, oh man. Oh, Abhishek, in that equation, the only problem is you have forgotten number of cubes which has no side painted. Aha, total minus three side painted minus two side painted will give you one side painted. What an intelligent answer, but I won't say you are completely wrong. It's a good answer. It's a very good answer, but the only problem is you have forgotten number of zero side painted. But I'm not asking you to give me this answer. Give me the answer that I'm expecting. Guys, not many of you. I know typing is tough. If you know the answer, you can just copy from others. If you have understood, just copy from others and paste it here. I'll get to know that you understood. Yo, Vidya, very good. Good job. Look, if you look at this front face, look, I'll rub this nonsensical purple lines. It's troubling a lot. If you look at this front face, if you look at this front face, um, in x direction there are x cubes, in y direction there are y cubes, but all the cubes are not two side paint, one side painted. I need to consider x minus 2 here and y minus 2 here. So total number of cubes that are only one side painted in this face is x minus 2 into y minus 2. But like this face, there is one more face in the behind. So I need to consider 2 into x minus 2 into y minus 2. 2 into x minus 2 into y minus 2. Similarly, if you consider this side face, it is 2 into y minus 2 into z minus 2. Plus, if you consider the top face and the bottom face, it is 2 into z minus 2 into x minus 2. So this would be the final answer. This would be the final answer. Put it here. I hope you guys were able to understand that. I hope you guys were able to understand that. Uh, Chalo, the next question, the next question, the final question. No side painted. How many of them are no side painted? Simple question. You had to go to the core. You had to go to the core. You slice out the top layer, the bottom layer, the front and the back, sides, right and left. You slice out 2 in every dimension. You slice out 2 in every dimension. Your answer would be x minus 2 into y minus 2 into z minus 2. That's all the answer is. X minus 2 into y minus 2 into z minus 2. Ankit and Abhishek, I have a question. Did you understand the previous equation? Did you understand the previous equation? Ankit, Abhishek. Abhishek, it was a good try. I won't say that. Now add this one also, it will be perfect. No sided painted will be x minus 2 into y minus 2 into z minus. There it was x minus 2 whole cube. But here all the directions are not same, right? Yeah, good. Sure. Congratulations, Abhishek. Very good, Vidya. Ankit also congratulations. So let's do a few problems now. You have understood. Chalo. These are all the diagrams that I've put. The good part is you guys were so good. Whoever at least responding, they were so good. I didn't need to put a lot of diagrams for to make you understand. This is a four dimension cube should look like, and this is called as tesseract. I hope you love Avengers and you know what is tesseract. Now look at this question and quickly answer. What's the answer? Give me answer. And now I'll just run through questions so that you will give me answers quickly. You have understood the logic. You have understood the logic. There should be no. Can you tell me in this question? Can you tell me in this question? Um, in each edge, how many cubes are there? No, Chandan. In this question, can you tell me what is x equal to? In this question, can you tell me what is x equal to? Very good, Abdul and Sandeep. X is equal to 3. X is equal to 3. Very good, Abhishek. Vidya, very good. X is equal to 3. So if x is equal to 3, can you tell me how many cubes are no side painted? Correct. 27. 3 into 3 into 3. Correct. 27 not divided by equal to 3 into 3 into 3. Not divided by. If you are getting 1 because 27 divided by 27, that's not the answer. And then that's not the answer. The answer is x minus 2 whole cube. Numerically, the value is still 1, but not that method. Don't do that method. So, how many small cubes got no side painted? Okay. For the same question, can anybody tell me? Oh, can anybody tell me how many cubes are there one side painted? How many cubes are there one side painted? Only one side painted. Only one side painted, Chandan. Only one side painted. Chandan always searches for the answer and then he thinks, हाँ दिमाग की बत्ती चल गई. Good Umar, good Abdul, good Vidya. Nice, nice boys and girls. Great people. Okay, move on to the next question. Stop. Enough of giving you. Ha. All surfaces of a cube are colored. Find the number of cubes with only one side painted, two side painted, and three side painted if cube is cut into 125 smaller cubes. Quickly, give me answer. Start with three side painted. Always start with three side painted. You have read the question now, right? Three side painted. How many three side painted, guys? Very good. Three side. Three side, three side. Three side one sate. Three side ಎರಡು ಸತಿ. Three side ಮೂರು ಸತಿ. How many of them are three side painted? Three side, 8. Sold. For 8 it's sold. Yeah. It was there for a long time. You guys did not hear. Three side painted is 8. Now two side painted. Now let's go to two side painted. How many are two side painted, guys? I'm not explaining anything here. And people, if somebody who's not understanding, please ask me. Please ask me and look at the answers that the others are giving. That means they know, they have already understood. That's why I'm not explaining much. That's why I'm not explaining much. Uh, if anybody is not understanding, it's your duty to ask me. If you don't ask me, how would I know? If I don't know, how would I teach you? Please understand. Um, two side painted, two side painted. Abhishek says 12, 12, 12. No. Abdul Sattar says 36. What's where do you find two side painted? You will find two side painted in on the edges. Edges means the order of the equation should be one line, right? So it is x minus 2. That's all. The answer is x minus 2. But how many edges are there? 12. It is 12 into x minus 2. X here, x in this question is 5. I hope at least that much you are able to understand. So 12 into x minus 2. Umar, Umar, please Umar, not 42 Umar. 12 into 12 into x minus 2. X minus 2 in this case is 5 minus 2. That is 3. 12 into 3 is 36. One side painted. One side painted. Now don't you think all these questions are joke because you know the logic? Where do you find one side painted? You will find one side painted on the faces. Faces means it should be a square equation. So it is x minus 2 whole square. It is x minus 2 whole square. 3 minus 2 whole square. 3 minus 2 whole square is face means area, right? I'm using that logic to understand whether it is x minus 2 or is it x minus 2 whole square or is it x minus 2 whole cube. Every case it is x minus 2 for sure. Every case it is x minus 2 for sure. But I don't know whether it is x minus 2 or x minus 2 whole square or is it x minus 2 whole cube. By understanding whether it is face, area or a line or a cube volume, I'll be able to decide that. No valid log available. Yep. So your final answer is 54 and 27. I think we can move on to the next question. All the best, guys. All the best, guys. Do I need to share an attendance sheet or something like that for this class? So Sandeep says four with red and black. How many cubes have only two colors, red and black? Eight with only red. How many colors cubes have only one face colored red? A wooden cube of side 4 centimeter has been painted with the different colors. The two opposite surfaces are painted red. Red. Abdul says red and black is four. Only Sandeep and Abdul so far has answered. Guys, do I want to explain this question for you? Hey Abdul, why did you change your answer? No, four was I think correct answer. Guys, do I need to share any attendance sheet for this group? Is there any attendance sheet? I forgot. Please let me know. Or is it automatically attendance is automatically taken by the portal? Yeah, attendance is automatically taken by the portal. Eight red and black. Huh? Okay, I'll learn this solve. Okay, a wooden cube of side 4 centimeter. Uh, okay, it's on portal, so you will take it on portal. So not to worry. I don't need to share anything. A wooden cube of side 4 centimeter has been painted with different colors. The two opposite surfaces are painted with red, and two other two colors are painted with green. Let's take that same color coding. Two are coded with red, two are coded with green. Remaining two surfaces, one is painted with white and another one is painted with black. Instead of white, I'll use purple. Okay, diagram looks like this. How many cubes out of the remaining two? So how many cubes have only two colors, red and black? So it is two color painted. Only two colors. That is, it is two side painted. Where do we find two side painted? We find two side painted on edges. On edges. So when we are talking here, x is equal to 4. I should have written a cube, but I have written a cuboid. Uh, Please manage. You can understand the difference, right? So two side painted will be found on edges. So edges means it's line. It should be a one dimension equation x minus 2. But now the question is, you need to understand where red line, red face, and um, red face and green, red and green, right? Red face and black face meets. Look, this entire surface is red surface. This top surface is also red surface. Top and bottom both are red surface. Only other surface, only one other surface as black. that the behind one as the black. Now you need to find the edges. Now you need to find the edges where the red surface and the black surface meets, and that edges I'll highlight it with yellow here. This is the edge, and this is the edge. These are the only two edges. These are the only two edges. These are the only two edges where red and black meets. These are the only two edges where red face and black face meets. So far, any doubts, guys? Red face and black face. Red face and black face meets at two edges. Only two edges. So your answer should be 2 into x minus 2. Your answer should be 2 into x minus 2. So it is 2 into 4 minus 2 is 4. 2 into 4 minus 2 is equal to 4. So the answer is 4, guys. 4. Painted with red and black is 4. You guys changed your answers to 8. I don't understand why. Red and black is 4. The next question is how many cubes have only one face colored? Red. Only one face colored red will be on two surfaces. This surface and this surface. Top surface and bottom surface. And how many of them will be there in that top surface, and how many of them will be there in the top surface and the bottom surface is the question. Look, top surface is made up of like 4 minus 2, 4 minus 2 whole square. Top surface and bottom surface you need to consider into 2. 4 minus 2 whole square is 2 square into 2 is 8. So answer is 8. Only red is, it's on the face. If it's on the face, face means area will be represented by a second order equation. You need to consider it like that. It will be very easy to relate. Line means a single dimension equation. Face means a two dimension equation. Volume means a three dimension equation. If you are able to relate it like this, I hope you will be able to get a good understanding. Please take the screenshot of these questions. Please take the screenshot of this question. I'll be ending this session little early because I have one more session to log into at exactly 4. So please bear with me, and extremely sorry I'm ending the session 5 to 6 minutes early. So please take the screenshot of these questions and try to solve this. The last question is a really tricky question. But if you understand the geometry and if you understand how to count, like I'll give you a clue. I'll give you a clue for the last question. Look, in this red, blue, and white that we started the session with. Totally, how many cubes are there? Small cubes are there? Totally, how many small cubes are there? You remember the beginning of the session, we started with the Rubik cube, red, blue, and white. Totally, now you can consider 7 only. Now you can consider 7 only. Don't consider x, consider 7 only. And tell me totally how many small cubes are there? Very good, Vidya. Total number of cubes would be 7 into 7 into 7. Now, can anybody tell me how many small faces are there? Faces. Spaces. Small cubes, right? How many small faces are there? How many small faces are there? How many small faces are there? Look, small face means face of a small cube. It is not 7 square into 6, it should be 7 cube into 6. Totally. Painted, out of that, painted is 7 square into 6. Good, Abhishek. Out of that, painted is 7 square into 6. But total number of small faces are 7 cube into 6. 7 cube into 6. Correct, Madhavi. 343 into 6. But others are also not completely wrong. 294 is not completely wrong. 294 means it is the painted surface, painted small faces. Painted small faces. But 343 into 6 means total number of small faces. If you understand that concept, I think you will be able to solve this particular question. Take a screenshot of it, go home and solve. And thank you for attending today's session. I had a wonderful time. Please let me know your experiences. I honestly, I did not had too wonderful time. There are only few people are responding. Next time when I come to the class, respond more. Okay. Yeah, please let me know how you felt about today's class. Please let me know, did I go very fast or very slow? Do I need to cover more problems, or you understood the logic, not understood the logic? If you find any problems, or even if you find anything so lovely about the session, please let me know. I'll be glad to read your feedback and try to understand what you feel. Of course, thank you all of you. Yeah, if you are saying thank you for me, welcome guys, but please let me know your opinions about the session today. I hope you enjoyed, but even then, please let me know in the chat box. I'll be reading it. Saying that, goodbye for the day. Enjoy the rest of the day. I hope we'll get to meet again. Thank you, Madhavi.